For example 5, it says, if f of x is equal to 1 over x, determine the fifth derivative of x. So, we're going to start with what f of x is equal to. F of x is equal to x to the negative 1. And then we're just going to make our way through. So the first derivative, f prime of x, is just going to equal negative x to the negative 2. The second derivative, the negative 1 times negative 2 is going to give me positive 2, and I'm going to have x to the negative 3. The third derivative, the 2 times negative 3 is going to give me negative 6, and now I have x to the negative 4. When I get to the fourth derivative, negative 4, negative 6 gives me positive 24, and I have x to the negative 5. And then for the fifth derivative, the 24 times the negative 5 gives me negative 120, x to the negative 6. Now, if I want to get rid of those negative exponents, I could say that this is the same as negative 1 over x squared, or this is 2 over x cubed. This is negative 6 over x to the 4. This is positive 24 over x to the 5. And this is negative 120 over x to the 6. So, if we're determining an expression for the nth derivative of x with respect to x of y is equal to 1 over x, then we can say that y prime is just negative 1 over x squared. We can say that y to the 2 is equal to 2 over x to the 3. We can say that y to the 3, which we already know is negative 6 over x to the 4. Y to the 4 is equal to 24 over x to the 5. And y to the 5 is equal to negative 120 over x to the 6. And what do you notice about those numerators? A pretty common pattern from Math 30-1, which means that we can say yn is going to equal negative 1 to the power of n, and I'm going to have in the denominator, it's always going to be 1 greater than whatever this was, so let's call that n plus 1. All right, for the last example, we are going to use implicit differentiation to find a second degree differential. This is a essential skill. So, first off, we're going to do the first differential. So I'm going to say that I'm going to take the differential of every term, and I'm going to get 3x squared plus 3y squared y prime is equal to, that constant is just going to become 0. Or 3y squared y prime is equal to negative 3x squared, and y prime, when I divide both sides by that 3y squared, is going to equal negative 3x squared over 3y squared. And the 3's are going to cancel out. And I'm just going to wind up with negative x squared over y squared. Then we're just going to use our quotient rule. To do the second level. So we're going to say that at the second level, I'm going to have my low, which is y squared, and the derivative of the high, negative 2x, minus the high, negative x squared, times the derivative of the low, which is going to be derivative of y squared, we know is 2y times y prime. And that's all going to be over the low, y squared, squared. Low d high, less high d low, draw a line, and square below. All right. Then I'm going to say that this is going to be equal to negative 2x y squared plus 2x squared y and y prime all over y to the 4. Well, wait a second. Don't we already know what y prime is? We solved it right there. We know that y prime is equal to negative x squared over y squared, which means that this is actually negative 2x y squared plus 2x squared y, and then negative x squared over y squared, all being divided by y to the 4. Well, in order to combine these, I have to put this one over y squared as well for the two terms, so I'm going to have to multiply the top and the bottom. Sorry. let's simplify that first. Let's take away a y from here and a y from here, make our lives a little bit easier. And we're just going to have to put it over y. So I need a y here, and I need a y up here. No point in doing extra work when we don't have to. So what do we have? We have negative 2x y cubed over y. And then when I multiply the negative into here, I'm going to have minus 2x to the 4. And this is all being multiplied by, if it's divided by y to the 4, multiplied by 1 over y to the 4. I'm going to expand along the denominator to get y to the 5. And I'm going to factor this numerator, pulling out a common factor of negative 2x. And what am I left with? Y to the 3 plus x to the 3. Well, we saw this in our initial equation. Our equation was y to the 3 plus x to the 3 plus y to the 3, which is the same as y to the 3 plus x to the 3, is equal to 5. Well, then let's just call that 5. Which means that this entire thing just becomes negative 2x times 5 over y to the 5, which is going to give me negative 10x over y to the 5. And there's the final answer.